There is this very specific feeling you get when you walk into the basement of an older house.
Oh, absolutely. The
Oh,
air drops a few degrees. It smells faintly of damp concrete and old dust.
right, exactly. And sitting right there in the middle of the room is a machine, a massive humming hunk of steel that looks like it could, I don't know, survive a direct asteroid strike.
Yeah, it just sits there doing its job exactly like it has been doing for decades.
And in that moment, looking at that absolute tank of a machine, it feels like you are staring at a piece of undeniable physical truth about how the world used to be. Welcome, by the way, to today's deep dive. We're so glad to have you here with us joining the conversation.
Yes, welcome. Because that feeling you just described, it is an incredibly powerful illusion. You see something enduring, something heavy and loud and old, and your brain immediately draws these massive, sweeping conclusions about the era that created it.
Because today, our mission is to uncover the hidden, honestly almost invisible psychological link between a perfectly functioning 41-year-old basement furnace and American World War II bombers.
Which is quite the leap, but it makes so much sense when we get into it.
It really does. We are pulling this from a fascinating reflection piece by Dave Hartzell. He's a master HVAC technician operating out of Kingfisher, Oklahoma.
And he has spent, what, 47 years in the trade?
Yeah, 47 years, which is nearly half a century of standing in those exact basements, looking at the very machines we just described.
And more importantly, it's 47 years of actually listening to the people who own them.
Exactly. So Dave's reflection reveals this massive cognitive blind spot that tricks every single one of us into believing the world used to be built better than it is today. And I promise you, by the end of this deep dive, you will never look at a vintage car, an old appliance, or even internet reviews the same way again.
It completely shifts your perspective.
So to understand how this trick works, let's start with a specific visit Dave made to a customer in a town called Calumet.
Okay, set the scene for us.
So Dave walks down into this basement, and he's confronted with a furnace from the late 1970s or early 80s. It's a Lennox. And the physical description of this thing is just amazing.
Built like a tank, I'm assuming.
Oh, totally. We are talking about a steel heat exchanger so thick you could literally drive a nail through it. It has a standing pilot light, a heavy-duty fan motor the size of a coffee can, and absolutely zero electronics.
Right, so no circuit boards, no microchips, nothing delicate.
None of that. It is 41 years old, and it is still just humming along perfectly.
And the customer, standing next to this really impressive piece of equipment, makes an argument that is, well, it's almost a universal reflex at this point.
Yeah, he points at the furnace and says, they just don't make them like they used to.
Right, he is absolutely certain that this specific physical furnace proves that modern heating systems with all their variable speeds and control boards are just over-engineered, fragile junk.
Okay, let's unpack this, because I have to jump in here and play devil's advocate for a second. If I'm standing in that basement, I'm probably agreeing with the homeowner.
It's hard not to.
Right. How can you argue with a machine that has survived 4 decades of brutal Oklahoma winters? The proof is literally sitting right in front of Dave, taking up physical space, doing exactly what it was built to do in 1981. Doesn't that heavily imply that the customer is actually right?
It implies it, sure.
No.
And the argument feels bulletproof because it is so tangible. You can knock on the fixed steel.
Yeah, it's real.
But this is where the illusion begins. Because the question isn't what the customer is seeing. The question is what the customer is entirely failing to see.
Okay.
We have to look at what we call the curated set of survivors. Dave notes a really critical factual detail about this specific neighborhood in Calumet. That 41-year-old Lennox furnace actually had 3 relatives.
Wait, what do you mean by relatives? Like other furnaces?
Exactly. There were 3 identical furnaces, rolled off the exact same assembly line, installed in that exact same neighborhood around the exact same time.
Wait, really? So there were 4 of these identical tanks on the same street?
Yes.
So where are the other 3?
They failed 20 years ago.
Oh, wow.
Yeah, the heat exchangers cracked, or the coffee can motor seized up, the gas valves failed. Whatever it was, they were disconnected, hauled up the basement stairs, thrown into the back of a scrap truck, and melted down.
Just totally gone.
Completely forgotten. And this brings us to the foundation of the bias we are exploring today, which is the visible signal versus the invisible noise. The homeowner in Calumet is making this sweeping evaluation about 1970s engineering based entirely on the visible signal.
While completely ignoring the invisible noise. And by invisible noise, you mean the 3 dead furnaces that aren't around to be counted anymore.
Precisely. The failures have literally been removed from the room. If a machine fails, it gets thrown away. If it survives, it stays in the basement.
So naturally, the only old things left for us to look at are the things that didn't break.
Exactly.
Yeah.
But human brains really struggle to process absent data.
Yeah.
We are very visual creatures. To really understand why our brains fall for this trap so consistently, we have to step out of that Oklahoma basement and go back in time.
I love a good historical pivot. Where are we going?
We need to look at a historical precedent that exposes the mechanics of this cognitive blind spot perfectly.
Let's do it. So we are traveling back to 1943.
Right in the thick of World War II.
Yep. The setting is Columbia University in New York. A group of the absolute smartest mathematicians in the country have been assembled into something called the Statistical Research Group.
And they are working directly for the military, right?
They are, and the generals hand them this massive, literal life or death problem.
The stakes were incredibly high here. American bombers were returning from missions over Europe, and they were taking heavy, heavy casualties.
Right. The planes that did actually make it back to base were just shredded. I mean, covered in bullet holes and flak damage.
So the military brass naturally wanted to add armor to the planes to protect the pilots and the crews.
Makes sense.
But armor is incredibly heavy.
Right. It's a huge engineering trade-off. You can't just armor a whole bomber in thick steel, or it becomes too heavy to get off the runway, or, it burns so much fuel it can't actually make it to Germany and back.
Exactly. You have to be incredibly strategic about where you put the metal. So the military officers did something that seems, on the surface, entirely logical.
They looked at the returning planes?
Yes, they looked at the returning planes, and they meticulously mapped out exactly where all the bullet holes were located. They gathered the data, looked at the clusters of damage, which were mostly along the wings and the tail, and they came to a conclusion.
Well, the natural assumption is, hey, look at all these holes. We need to put the heavy armor right here on the spots that are taking the most damage from enemy fire.
Right.
It makes total intuitive sense. If you are constantly getting punched in the ribs, you put on a rib guard.
It makes perfect sense, right up until a mathematician named Abraham Wald looked at their maps and told the top brass of the U.S. military that their intuition was completely backward.
He literally told them they were looking at the wrong planes entirely.
Yes. Wald essentially tells these battle-hardened generals that they are only analyzing the planes that survived the missions.
The planes that took fatal hits, the ones that were actually shot down by anti-aircraft fire, well, they are not in the hangar for them to study. They are burning in a field in France or sitting at the bottom of the English Channel.
So Wald realized that the clusters of bullet holes on the returning bombers didn't show where the planes were most vulnerable.
They showed the exact opposite, didn't they?
They showed the exact places where a bomber could take a heavy hit and still manage to limp back to base.
That is just wild to think about. The fatal hits were actually the spots on the returning planes where there were absolutely no holes.
Exactly. The engine bays, the cockpit, the wing roots.
Because if a plane got hit in the engine, it didn't come back to have its bullet holes counted.
Right. So Wald tells the military, don't armor the places with the most holes. Armor the places with no holes at all. Those are the silently fatal hits.
It is such a stunning reversal of logic. I mean, it's like conducting a massive survey to determine if skydiving is a dangerous hobby, but you only mail the survey to people who are currently alive.
That is a great way to put it.
Your results are going to be a little skewed. You'll get a 100% response rate saying, oh, skydiving's perfectly safe, I've done it 20 times, and I feel great. You are structurally filtering out anyone who could tell you otherwise.
What's fascinating here is that your skydiving analogy captures the exact mechanism of what psychologists and statisticians now formally call survivorship bias.
Survivorship bias.
Yes, it's a concept that thinkers like Leonard Mlodinow in The Drunkard's Walk and Daniel Kahneman in Thinking Fast and Slow have really popularized.
So how do we define it officially?
Basically, we draw broad conclusions about a population like the safety of skydiving or the durability of 1970s appliances or the effectiveness of bomber armor by only observing the members that successfully survived a very rigorous selection process.
We treat the surviving sample as representative of the whole.
Exactly, entirely forgetting that the process of survival itself completely skewed the sample.
Okay, so if we bring this historical insight back to Dave Hartzell and the HVAC trade down in the basement, that 41-year-old Lennox furnace in Calumet is just a World War II bomber that happened to make it home.
That is the exact connection. The customer in Calumet has zero access to the losers of that 1980s production cohort.
Right. All the identical furnaces built in 1981 and 1982 that failed in the normal 15 to 30-year window, they have been completely removed from observation.
But, this still leaves a very practical question hanging in the air.
Yeah.
If it wasn't the supposedly superior 1970s engineering that made things indestructible back then, what actually made this specific furnace survive for 41 years?
While its three identical neighbors went to the scrapyard 2 decades ago.
Exactly. Dave breaks this down with very specific, honestly unromantic mechanical reality from his source text. It wasn't just the era that saved it. It was ideal conditions.
Let's actually unpack those exact factors because it reveals so much about how these machines really function in the real world.
First, Dave notes the furnace was located in a dry, conditioned space.
Okay, so why does that matter so much?
This is crucial because a furnace is essentially a giant metal box. If you put it in a damp, unconditioned crawl space, the metal simply rusts from the outside in over a few decades. This one was kept dry.
Makes sense. What else?
Second, it was on a dedicated electrical circuit with stable voltage.
Now, wait, why does stable voltage matter so much for a machine with no electronics? I mean, you said it didn't have any circuit boards.
It matters because of that heavy coffee can fan motor. If a furnace shares an electrical circuit with other major appliances, the voltage can slightly drop when those other appliances kick on.
Oh, like when your lights dim for a second when the vacuum turns on?
Exactly. And over decades, those subtle voltage drops cause the furnace motor to run hotter and work harder. That slowly degrades the copper windings inside the motor until it shorts out. But this furnace had clean, dedicated power.
Okay, what else? Dave mentions it wasn't overfired, which prevents something called short cycling. I've heard that term, but what is short cycling actually doing to the machine?
Short cycling happens when a furnace is too large for the square footage of the house. It blasts a massive amount of heat, warms the house up in like 5 minutes, and shuts off.
Okay.
10 minutes later, it turns on and blasts heat again.
Mm.
This rapid on and off cycle forces that thick steel heat exchanger to rapidly expand from the intense heat and then contract as it cools down over and over and over again.
That's like bending a paperclip back and forth until it snaps.
Exactly that. Eventually, the metal gets fatigued and cracks. And a cracked heat exchanger leaks carbon monoxide, which means the furnace is instantly condemned.
Oh.
But this specific furnace was perfectly sized for the house, so it ran in long, gentle cycles. It had correct airflow, minimizing thermal stress.
And finally, there is the most human element of all. It had a homeowner who actually bothered to change the air filters regularly.
Which is paramount. A clogged filter suffocates the system. When you look at all these factors combined, you realize this furnace's survival is mostly a product of meticulous maintenance, a perfect physical environment, and, quite frankly, pure statistical luck.
So the other three identical furnaces on that street were likely installed in slightly damper basements, or were slightly oversized, or had owners who forgot the filters.
And so they tore themselves apart 20 years ago.
Dave has this brilliant quote in his reflection that summarizes this perfectly. He writes, "The survivor cannot speak for the population. The survivor can only speak for itself."
It's so true. You cannot look at a sample selected purely by the fact that it happens to still be running and draw a valid conclusion about the thousands of units that failed and disappeared.
Okay, so we've established how survivorship bias makes us look at the past through rose-colored glasses. The failures rust away in junkyards, leaving us staring at the single indestructible tank, which tricks us into thinking everything used to be built like a tank. But Dave points out something equally fascinating in the modern day. This exact same psychological blind spot runs in reverse when we look at the present.
Yes, the reverse bias.
Yeah.
If the past looks indestructible because the failures are hidden from us, the present looks incredibly fragile because the successes are hidden from us.
And nothing amplifies this reverse bias quite like the internet. I mean, the internet is basically a massive engine for curating failure.
Oh, absolutely. Dave uses the example of modern heating equipment to show how people view new stuff today.
Say a customer is researching a new, high-efficiency furnace, and they go online to read reviews. They stumble onto a forum post about 3 specific control boards that totally failed straight from the factory due to a manufacturer's bad batch.
And how does the customer process that information?
Well, here's where it gets really interesting. They immediately conclude that all modern high-efficiency furnaces have terrible, fragile control boards. They read those 3 bad reviews and think, see, modern stuff is over-engineered junk. It's an incredibly relatable trap. It's like assuming every single restaurant in your entire city is an absolute nightmare because you only read the angry, all caps, one-star reviews on the internet.
Right, completely ignoring everyone else.
Yeah, completely ignoring the thousands of people who went out, quietly ate a fantastic dinner, paid their bill, and went home to sleep without ever logging onto a forum to write a post about their totally normal evening.
Dave actually uses a brilliant phrase to unpack this. He calls those complaining forum posts the survivors of attention.
Survivors of attention. I like that.
Think about the selection process happening there. The complaining forum post is actively selected by a premature failure. The hundreds of thousands of complex control boards that are silently working perfectly in basements across the country right now, they aren't on the internet.
They have absolutely nothing to say. They are too busy heating houses to complain on a message board.
Exactly. So neither the 40-year-old surviving furnace in the Oklahoma basement nor the angry online complaint about the brand new furnace is a random representative sample of reality.
They're both highly curated extremes. One is selected by extraordinary survival, the other is selected by extraordinary failure.
And our brains fundamentally struggle to recognize that the vast, silent majority of normal, everyday experiences are entirely missing from our view.
So what does this all mean for us practically? Because, knowing about a cognitive bias in theory is one thing, but dealing with it face-to-face with another human being is totally different. How does Dave handle this?
That's a great question, because he's a technician. He's standing in a guy's basement.
Right. The homeowner is beaming with pride over his 41-year-old Linux. Dave can't exactly pull out a whiteboard, diagram survivorship bias, and tell the guy he's the victim of a psychological fallacy. That would be so condescending.
He definitely doesn't do that. And that highlights the most impressive part of Dave's 47 years of experience. He understands the human element of persuasion.
Because nobody wants to be told their beloved vintage possession, something they take pride in maintaining, is just a statistical fluke.
Exactly. He knows that directly contradicting the customer's reality just doesn't work. Hitting someone with statistical base rates and probability models usually just makes them defensive.
So what's his strategy?
Well, Dave starts by respecting the furnace. He acknowledges that the machine has earned the customer's love. It really has served him for 4 decades. That is a real physical accomplishment.
Okay, fair enough.
But when the customer asks him directly if modern furnaces are worse, Dave simply says they are different.
Okay, I have to push back on Dave here for a second, on behalf of the listener. Are you really telling me a delicate circuit board that fries in 5 years because a drop of water hit it is just different than a massive steel tank that lasts 40 years? Isn't a 5-year lifespan objectively worse?
It depends entirely on what you're optimizing for. This is where Dave explains the trade-offs of modern engineering. Yes, a 1970s furnace was built like a tank, but it was also horribly inefficient.
It sent a massive percentage of the heat you paid for straight up the chimney, right?
Exactly. Modern furnaces are designed to extract almost all the heat from the combustion gas. So much heat, in fact, that the exhaust turns into a highly acidic, corrosive liquid condensation.
Oh, wow. So the modern machine is dealing with acidic water constantly running through it just to hit those high efficiency standards.
Precisely. And to manage that complex process, plus provide varying fan speeds so your house doesn't feel like a wind tunnel, you need computer boards. Computers plus acidic condensation plus a damp basement means, naturally, varying lifespans and more potential failure points.
So Dave tells his customers he has data from nearly half a century covering both eras.
Right, he validates a softer version of their belief. He admits some old equipment was indeed incredibly durable, but points out that a lot of old equipment was also absolute dangerous junk.
The junk just isn't sitting in the basement to point at anymore because it got hauled away in 1995.
Exactly. And for most customers, that nuanced explanation of trade-offs is enough. They feel heard, they keep their furnace, and life goes on.
But inevitably, a few customers push back hard. They really want to vigorously defend that strong claim about the good old days being objectively superior.
And that is when Dave brings out Abraham Wald and the bombers.
He holds the World War II bomber story in reserve for the hardest cases.
Yes, and if we connect this to the bigger picture, this reveals a crucial lesson in how to communicate complex, counterintuitive ideas. Abstract statistics fail to persuade people because the bias itself isn't housed in calculation.
The bias is housed in what is physically present in the room. It's housed in the giant humming steel machine right in front of them.
Exactly. You can't beat a tangible object with a spreadsheet. To counter a powerful physical image, you need an even more powerful mental image.
Like military brass armoring the wrong planes.
Yes. The vivid story of the military brass wanting to armor the wrong parts of an airplane, and a lone mathematician realizing the fatal hits were on the planes that were currently sitting at the bottom of the ocean. That narrative bypasses human defensiveness entirely.
It makes the invisible, missing data suddenly visible in their mind. They can instantly picture the bombers going down over Europe, and in doing so, they can finally picture the broken furnaces sitting in a scrapyard 20 years ago.
It allows Dave to respect the customer's deeply held bias without ever actually ratifying it as truth.
That is just brilliant. This has been such a revealing journey. To quickly summarize what we've unpacked today for you listening, our brains are constantly being tricked by absent data.
We really are.
Whether we are looking at historic houses that seem incredibly sturdy, or vintage cars that are still on the road, or a heavy-duty appliance from the 1970s, we are evaluating a highly curated set of survivors.
We assume the entire era was robust, when in reality the era produced both massive winners and massive losers.
The losers just exited the stage a long time ago, leaving only the lucky winners behind to testify. And on the flip side, the internet curates failure, making the present look far more fragile than it actually is.
It is a lens that permanently changes how you view almost everything in the world around you. And to that end, I want to leave you with a final thought to mull over, applying this concept to entirely new areas mentioned in the broader context of the source material.
Where else are we getting tricked by this?
Next time you are scrolling online and you read one of those breathless articles about the daily habits of centenarians, this woman ate bacon every day and lived to 105 fun, or you read a best-selling book about the business secrets of highly successful billionaires, I want you to ask yourself the Abraham Wald question.
Where are the missing planes?
Exactly. Where are all the people who did these exact same things, who ate the exact same bacon, who woke up at the exact same time, who took the exact same massive business risks but completely failed? Who isn't in the room right now?
Because until you consider the invisible noise, you can never truly understand the visible signal.
Perfectly said.
You always have to look for what isn't there. Next time you walk into a cool, damp basement and see a machine humming away, smelling faintly of dust, just remember, it's not a time machine proving the past was perfect. It's just a bomber that was lucky enough to make it home. Thank you so much for joining us on this deep dive today. We really appreciate you being here.